This conference will now be recorded.
Once again, I want to check with every one of you. Am I clearly audible? Can someone please unmute and respond?
Yes, sir.
Clearly
Yes,
audible. If there is
yes.
any disturbance in the audio or anything like screen lag, just let me know. But it should be good. So we have tried fixing so many ways and we fixed it. There were no issues with the previous batches and all. It's not. It's a cache related issues only. Okay. So we'll start in a minute actually, but before that, let's try to recollect what we have done in the last two regular classes. So far we are done with only two regular classes where, so two regular classes, that is regular class 1. Please be on mute everyone. Please be on mute. You do not show any of your cameras or something. Just who is talking? Okay, please be on mute always. Okay, regular class 1. Regular class 1, we have discussed about application comma types of. You should be always on mute, please help me. Okay, so I do not want to make it like option. I do not want to remove. I'm giving the option to unmute, but make sure you are always on mute. Okay, application comma types of applications. This is what we have discussed, and advantages and all. Regular class 2, that's a practical session. So practical about application creation, that is framework application, implementation application. This is what. So after the theory part is over, we discussed about practical part. So the next topic we are going to discuss about, is class. First I will explain you class. After I explain you about the class, we are going to discuss about object oriented programming concepts. So there are some concepts related to object oriented programming system, that concepts we need to learn, because those concepts we are going to apply while working on PEGA without any coding. Okay, so first I'll explain you what is a class. Just in a simple way I'll explain you. I'm not going to use any technical terminology. I'm just going with paint to explain you what is a class. So before we discuss about class, we have already discussed about application. We have already discussed about something called as application. What is an application? Application is a container of functionalities. That's what we have already learned. Application is container of functionalities. Suppose if you take this is an application. Suppose this is an application. So this is one application, imagine. Otherwise I can, okay, let it be, no problem. This is one application. Let's say any application. It can be application A. Application name is application A. Generally, as per the definition I have given you, application contains functional components. Functional components, whatever you create, you are going to create inside application. But that is true, but up to certain level. But let me explain you the next thing. That is, inside an application, we can have one or more classes. What we can have? We can have one or more classes. These are called classes. Let's say this is class A. What is this one? Class. What is class? I will tell you. I did not tell you about the class, I know, but let me explain you about that soon. Class B. Two classes are there. Then where do you create the functional components? Whether the component may be user interface or business logic or database related. Any component here in PEGA is called as rule. What do you call it? Rule. So the rules are functional components you create inside the classes. Where do you create? You create inside the classes. Please be on mute. Kind request, please be on mute. Kind request. Whenever you have doubt, you can unmute and ask me and mute back immediately. Please always be on mute. That will not disturb any others in the meeting. Okay. Okay. Now here you go. This is functional component 1. Functional general. This is general language terminology. Functional component 1. So this one, I'm going to choose it as 10, something like that. Functional component 1. Okay. And the second one is, this one is functional component 2. So two functional components are there. In this class, again, it has functional component 1, but I'm not writing 1, I'm writing 3 to make it different. That is different one. These are different one. So like this, ultimately, your functional components are available inside application. That's what on day one I told. But actually, your functional components are available inside classes. Your application is, it's like a box. Inside the application box, what do you have? Classes. Again, class is like a box. Inside that small box, what do you have? Functional components. Just you can easily imagine. You know small boxes, right? So suppose you have your lunch box. So lunch box you open. Inside lunch box, there can be another box, small box. Inside that second box, you have some curry prepared. Okay, you have that, right? Same way, you have first one, the overall one, application. If you go inside application, functional components will not be directly in the application. Functional components will be there inside the classes. Those classes are inside application. Ultimately, functionalities we can say inside application. On day one, I did not talk about classes. I just told about application. Application is container of course, functional components. But how application contains classes? Classes contains functional components. These classes, these are the classes wherein which your functional components will be available, and these components are executable. These components are executable components. Understand? You can execute these functional components. I will just save this diagram in your 624 batch, right? And here this is application, class, functional components. This is a general idea and information. Then technically, what is a class? Technically, what is a class? If you ask about a class is a unit structure. Class is an unit structure. Class is a unit structure. Unit structure means which will have what will be there inside a class? Functional components, which will have functional components. So inside a class, functional components will be there. Okay, so classes are executable. Generally we say classes are executable. Class is executable unit. Executable unit, generally we say like that. But okay, it accepts an input. It accepts an input an input, and comma, process it, and generates an output will be generated. Actually, components will be executable, those will accept, but for an outline we experience like classes are executable. Okay, so class is a unit structure inside which you have functional components. Class is executable unit. It accepts an input. Class is executable unit. It accepts an input, comma, process it, and generates an output. So now you are going to create classes inside your application. So what is an example to have class in real world where you can see this type of structure? Application inside classes, classes inside functional components. Let me tell you. Just imagine in the real world. In the real world, we have a bank. In the real world, we have a bank. So bank is there. So bank is your application. Entire bank is your application. You can imagine it like a physical building. A building is there, that is bank. That is entirely called as one application. So inside bank, what do you have? Inside, if you go inside bank, there are different rooms. There are different rooms. Each room you can say one department. So let's say for example, loans department is there. Loans department is there. Loans department. And what else? Next one, insurance department is there. Insurance department is there. And what else can be there? Let's say cards department is there. Cards department is there. And verification department is there. Verification, DEPT stands for department. DEPT stands for department. So just imagine these are 4 rooms inside that building. Okay, inside application 4 rooms are there. One room, each room has a board: loan department, insurance department, card department, verification department. So what happens in the loan department? Tell me what happens in the loan department. Loan transactions gets initiated in the loan department. Loan transactions gets initiated. And what about insurance department? What will happen in the insurance department? Insurance policies transactions will be done. And what about cards department? Cards department means maybe debit card or credit card, card issuance, and any other things. Card issues will happen here. Okay, and verification department, what will happen? verification of verification of let's say address. Okay, verification of address and credit score. Okay, CS stands for credit score. Such things will be verified by verification department and all. So these are the activities that will happen inside the bank. So now bank as an application, each department you need to consider as a class. Inside each department, the respective I mean, like functional components will be there. Utilizing those things, people can make the transaction. Suppose if a customer is going to go to bank and there he want a loan, he will go to loan department. At the loan department, loan transaction will be initiated by collecting the documents and necessary actions will be taking place further. And then similarly, insurance policies will be processed in insurance department. Insurance policy will not be processed in loan department, correct? And cards will not be issued in insurance department, each one dedicatedly available. So this is the reason why it cannot be done. Can all these things be done within a single department? Generally, practically, is it possible or not possible? All these activities, anyone comes, only one department is there. We issue cards, we issue insurance, we issue loans, we do verification. Is it generally practically possible or not possible to do? It is practically possible, but what is the problem if you do such things? What is the problem?
Tax
No.
and management,
I will tell you
risk
another.
management.
Okay, I will tell you another example. That is, you have a cupboard. Okay, the cupboard, in the cupboard, you have your dresses. You have different types of dresses. Like you have party wear, you have ethnic wear dress, you have a regular fit, okay, casual dress, and you have an official wear. Means while going to office, you will be wearing. Okay, so all these type of many dresses are there. Okay, and everything you just added just like one heap there. Okay, so is it easy or difficult for you to pick one specific type of dress from that particular heap? Is it easy or difficult? It is difficult. Ultimately, you can bring it out. Okay, but it is difficult, no? Okay, so it is difficult. But instead of this, your cupboard you divide it into 4 different racks. So you label it: first rack ethnic wear, second rack, okay, party wear, third rack casual wear, fourth rack and official wear. Okay, so now your dresses you are going to hang in the respective rack. Now is it easy for you to pick a specific type of dress that you want? Is it easy or not? It is easy for you. Suppose your friend comes to you your room, and for him also, is it easy or not? For him also it is easy. Now this segregation is going to make it easy for anyone to identify it, okay, and easy to access it. That's why we can do everything in one place, but it will be clumsy, right? That's why you divide it, segregate into. This is called modeling. What is this called as? Modeling. We'll talk about the technical terminology later. So now you have to model the things. So instead of keeping everything at one place, you divide it. That's why one application can have multiple classes. One application can have multiple classes. Each class contains the respective functional components that are useful at that particular class for the transaction making purpose. Understand clear, every one of you? Are you clear so far? So in an application, in your business application, how many classes you will be having? I don't know. There can be n number, depends on requirements. Okay, how large is your application? So many functionalities, so many things, so many classes will be there. Clear? Makes sense? This is what about application and inside classes. Okay. Now, will there be any such need? One class wants to access the features of other class. One department wants to take some features, some help in doing the task, some features that they wanted to, or some functional components that they wanted to access from other departments. Will there be any such need generally in the real world?
Yeah.
Will there be any such need? Yes or no?
No.
Yes, obviously there
Yes.
will be such need. A department may have to contact another department requesting for something in order to complete the tasks. Every department cannot do everything sole, okay, on a solo manner. Now, Here if you look at this, loans department, insurance department, card department, and apart from these three, one more department is there, verification department. So verification department involves in doing the activities of verification. Okay, is the verification related to only loans, only insurance, only card, or anything? So if a person applies for loan transaction will be initiated at the loan department. During the transaction processing, the file will be transferred to verification department. File will be transferred to verification department. Now verification functional components gets executed to perform the verification that is needed by loans department. In the same manner, insurance department also requires it, cards department also requires it. So how these functional components will be utilized, how these functional components will be utilized by other departments, utilized means accessed by other departments. In order to access the functional components of one class into another class, we need to come up with defining a relation between the classes. What do we need to define? A relation. If you have a class, this class functional components I need to access at runtime. Okay, so I have to create a relation, I have to define a relation between the classes. That relation in technical terminology you call it as inheritance relation. What is you call it as? Inheritance relation. Inheritance is a relation defined between, as of now, two classes, defined between two classes, where the class which provides the which provides the functional components. Functional component I can write like this, FCs. Functional components is parent class, is called as what? Parent class is called as parent class. Sorry, parent class. Whereas the class which is requesting FCs from another class is called as what? Child class. Is called as child class. One parent class may have multiple child classes. One parent class may have multiple child classes. It is possible. A parent has two children. That means two children can commonly access the components from parent class. This is what I told you. Laptop is there with the father. Child 1 can utilize it. Child 2 can utilize it. Anyone can access. That is a hardware. I'm talking about in a software point of view. They can access at a time. So now look at here now. So I'm going to draw one diagram here for the inheritance purpose. Okay, so here you go now. So this is, oh, I'm sorry, I'm going to do like this only. I'm going to choose this way only. I'll use boxes only. This is better. Okay, so this is, let's say for example, this is class A. This is class A. So if class A is parent class, let's make it as a parent class. Let's make it as parent class. Class A is a parent class now. So it has some functional components. What are the components names? F1 and F2. Let's give it as F1, functional component 1, and this one is F2. Okay, functional component, okay, FC1, FC, okay, that's okay. Okay, functional component 1, F1 F2 అంటే మళ్ళీ సినిమా అనుకుంటారు, అందుకని ఆ దరిద్రం తీసేస్తున్నా. FC1, FC2. So your mind will change and go there somewhere else. FC2. Now here you go. Two classes I'm going to draw below. Class 1, class 2. Class 1, class 2. And in the class B, class C. Let's say class B, class C. So class B, class C, these are parallel level. These are parallel level means what? Siblings. Child 1, class C. Class C, that is child 2. So these two children are siblings. Siblings cannot access from each other. Siblings cannot access from each other. Now this class can access. So now FC1, where is it? I want to have this line. I mean, like, FC1 will be accessible to this one when there is a relation defined. When there is a relation defined, this is called inheritance relation. This is called, so class C is inherited from class A. Class B is inherited from inheritance. This is what? Inheritance relation. This is what? Inheritance relation. Okay. So now these things are accessible now. These things are now accessible. I'm just going to draw it like a thin one. Okay. Now FC1 will be accessible here. FC2 will be accessible here. I'm sorry. I'm just going to do what? So here I'll do. So class C can access FC1, FC2, and class B can access FC1 as well as FC2. So FC1 will be accessible here as well as FC2 will be accessible here. Functional component 2. Here also functional component 1 will be accessible. Functional component 2 will be accessible. This is a kind of reusability. What is this called as? Reusability. Okay. This is inheritance. Inheritance. Understand clear everyone? This is the concept of inheritance. Object oriented programming language, we call it as inheritance. So what is the advantage? See, in a component, when a component is a common component, so for class B it is needed. For class C also we need the same component, one or more components. Common components of siblings we create at the parent classes. We create at the parent classes. Common components of siblings we create at the parent class, so that sharing. Okay, the class B can access, class C can access. You don't have to create two times. FC1 you don't have to create two times. Creating only at one place at one time, you are accessing at two places for two different reasons or maybe some other purpose. Understand clear everyone? This is also kind of reusability. Inheritance advantage is advantage of inheritance. Advantage of inheritance is reusability. While we create our application and application classes and functionalities, we need to always think about reusability. We need to always think about reusability. Reusability, time saving, yes or no? Time saving. Okay, and then what else? Cost reduced. No redundancy, no duplication, similar to framework implementation. That is also same concept. I'll come to there also. This is clear everyone? Makes sense? Generally I'm explaining. Everyone clear? So whenever you are going to work in PEGA, you will have so many classes. Okay, in PEGA our application also will have multiple classes. You create a component inside some class, but you need to think about, should I create in the child class or should I create in the parent class? Any specific component that is only needed for one child, you create in the child class. Any specific component that is related to only child class C, you create in the child class. Common components you create in the parent class. So higher level parent classes will be there, lower level child classes will be there, generally speaking in a diagrammatical representation. Make sense? Clear everyone? So these things we are going to use. Now I will tell you the same inheritance concept when we have multiple applications. When we have multiple applications, listen to me carefully. These things you will apply for lifetime. These are concepts, no? When every time you are creating every rule, you have to think about these concepts and you have to properly apply these concepts. Now I will take paint once again. Okay, third diagram, inheritance continuation only. Okay, because I have to make it clear for all of you these things, otherwise you'll get confused. Now two applications. How many applications? Two. Built on application plus implementation. Built on application and higher application. One or more higher applications. Let's take only one. If I tell you with one higher application, that is common for all other. Now here I am going to draw one built on application. This is built on base level framework application. And on top of framework application, what do you have? One or more implementations? No. Let's take one or more implementation. Okay. Let's take one implementation here. If you want to draw another implementation, we can draw. Okay, let's take one implementation for now. Let's take second implementation also. Let's say Alex. Implementation 2, implementation 2, implement framework application. This is bottom one is what? Okay, I'll write down side by here. Just give me 1 minute. This is, this is, this is. Okay, here you go now. This is framework application, framework application. And here what am I going to do? Just give me 1 minute. I'll have to utilize the space properly. I'll draw here. Okay, and here you go now. Implementation 1. Oh, it's taking everything. Okay, implementation 1, implementation 2, implementation 2. Two implementation applications are there. Two implementation applications are there, and one framework application is there. This is at the very bottom. I am writing here framework application. I'll increase the font. Give me a minute. 20. This is framework application. Then what about the other one? This is implementation 1, implementation application. Let's say A, application A, implementation application A. I'll take it as 14 and I'll make it in a single line. Implementation application A, and this is what? Implementation application B, implementation application B, implementation application B. Okay, so two applications are created on top of one framework. Possible. These two implementations are siblings. These two implementations are siblings. Inside the framework, you have one class. You can take even multiple classes. Okay. Otherwise, we'll take two classes. Class A, class B. Class A and class B. Two classes will take. Maximum space I want to utilize. Class A and class B. Two classes are there. Now here you have one class, one or more classes here also. I am taking only one class. This is class C. This is class D. This is class D. So look at here now. This is, what is this one? Class A. I'll write down at the bottom. Class A. Class A is there in which class, which application? Framework. What about this one? Class B. Class B is in framework application. What about this one? Class C is in implementation 1. Class D is in implementation 2. Now I am asking you one question. That is, here you have functional components. So here one functional component is there, FC1. What is it? FC1. Okay. What about this one? Here also you have one functional component, that is FC2. 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 Clear? Everyone clear? Now the question is, I want to access. Okay, here I have drawn it like a stack. I have drawn it like a stack, one on top of another. Can this functional component 1 be accessible from class A into class C? Yes or no? Can I access functional component 1 which is available in class A into class C? Is it possible or not possible? That's my question. Generally you say yes. Why you said yes? Because implementation application is created on top of framework application. As a result, you will be able to access. That's what we discussed. But remember this point clearly. If you want to access a functional component from one class to another class, from one class to another class, what is mandatory relation? What relation must be there? If you want to access the functional component of one class into another class, what relation must be there? Inheritance relation must be there. There is no inheritance relation between two classes. Is it possible to access the functional components from one class to another class? No, not possible, correct? In the same sense, you tell me, is it possible to access the functional component FC2 of class B into class A of framework application? It is not possible. Why it is not possible? Because there is no inheritance between class A and B. Those two classes are available in the same application. When two classes are available in same application, you are not able to access from one application to another application. How can you access from another application class into application A classes into application B classes without inheritance relation defined between classes? It is also not possible. If you want to access class A functional component into class C, where the classes are available in different applications, I did not draw any inheritance relation. I did not draw any inheritance. Without inheritance, how is it possible? Within same application itself, if it is not possible, within different applications, how it is possible? It is not possible. If you want to access, what do you need to define? You need to define what? Inheritance relation should be defined between the classes. Inheritance relation should be defined between the classes. That is mandatory. So you must be defining inheritance relation between the classes. This class should be inheriting, means C is coming from A. So then only it is possible. But why I am facing? This is looks good. It's okay now? Good. Able to hear? Yeah, I'll repeat again. Okay, able to hear, right? See, what I'm trying to tell you is when two classes are there in the same application, you are not able to access the functional components from one class to another class unless there is inheritance relation defined. In the same sense, how can you access the functional components of another application classes into current application classes when there is no inheritance defined? You cannot access, obviously. That's why even though you created implementation application on top of framework application, you must define inheritance relation between the classes. So the classes must have inheritance relation defined even though the classes are from framework and implementation applications. Framework and implementation applications, though those are framework and implementation application classes, you must define inheritance relation between the classes. So here also you should be defining these things. You need to remember. Okay, so we'll be learning it soon. Okay, practically we are going to experience all these things. Inheritance. So here is the inheritance relation defined between the classes. Clear? Makes sense, everyone? So our aim is to define an inheritance relation between classes if you want to access the components from one class to another class. Whether the classes are there in same class, whether the classes are there in different class. I can define inheritance relation here because the class D is available in implementation which is created on top of framework. I'm going to give you a clear idea. Just wait. I'm going to draw one more thing here, which is another framework, which is some other application, some other framework application or something. So here you go now. This is a framework, another framework application B. Let's say not B, some other framework 2, framework application 2. Is it a framework for above? Are those implementations created on top of this framework? No. The above implementation applications have not been created on top of this framework. Okay, this framework has some classes. This framework has some classes, and inside these classes, it has a functional component FC3. FC3 is there. Now you will get a clear idea. See, FC3 is there. Now I wanted to access the functional component FC3 of another application into my implementation B. How is it possible? You should define what? Should define what? Inheritance relation between these two classes. Yes or no? Yes or no? You should define inheritance relation between these two. Able to access. This is inheritance. This is what? Inheritance. Now can I access yes or no? I can access. But the point here is you cannot define inheritance relation between these two classes. We cannot define inheritance relation between these two classes. Why we cannot define inheritance relation between these two classes? It's not about multiple inheritance. Leave about multiple inheritance. It is possible in PEGA. Leave about, don't go technical. I'm not speaking anything technical here. Just tell me generally. Generally, you tell me. Okay. So generally, it is not possible. Why it is not possible? It's not about only one parent. It is multiple inheritance is possible in PEGA for your information if you're a technical person. It is possible in PEGA. Leave about the concept of multiple parents, multiple inheritance. That is possible in PEGA, though it is possible. Here, I'm saying defining inheritance relation itself is not possible. Making, it's not after you make the parent, I'm not saying it won't accept. You cannot even define a relation between these two. The reason, you know what? The class, this one, no, this, what is the class name? I'll give some class name, no, class E. The class E is available in an application which is not at all connected with these implementations. See, defining inheritance relation between classes of different applications is possible only when these applications are connected with framework inheritance implementation relation. So by creating an application, implementation application on now am I audible? Yes, audible, right? Yes, listen to me. what I'm trying to explain is, in this scenario, class E, between class E and E, be able to define inheritance relation. You will not even be able to define. Why you not be able to define inheritance relation? You know, the reason is these two applications are not in connection. Okay, if you want to define inheritance relation between two classes, the class application one thing, or the classes may be in different application. These two applications may be having framework and relation. Understand clear, everyone? In the same manner, is it possible to define possible? You can unmute and say, is it possible to define inheritance relation? Only with your batch. Morning it was very good. I did everything what I have to do. Morning also it is very good. Is it audible now? Is voice breaking or audible?
Yes, sir. We can,
So now the
we
question
can hear.
what I'm asking is it possible to define inheritance class D of implementation application B with the class A of implementation application C? Is it possible to define inheritance relation between the classes C and D? Is it possible? Yes or no? What do you say?
No.
Not
Yeah,
possible.
right.
It is not possible because these two applications are siblings. These are different. Though these are built on the same foundation, so for application A and application B, each other, these are different. So you cannot define inheritance relation between the classes of C and D. You can define inheritance relation between the classes B and D, or A and C, or B and D, C also possible or not? A and C, D also possible. When you want to define inheritance relation between different application classes, one application must be framework, another one must be implementation. Between two implementations, you cannot define inheritance relation. You cannot define inheritance relation between classes of other applications which are not at all related. I'll write down these points, don't get confused. I'll draft it. So we can define inheritance relation between two classes when first point, the two classes are in same class, same application. The two classes are in same application. The two classes are in two different applications.
We can hear you now, sir. There is no issues now. We can hear you.
Okay, but you can hear me, but I'm so sorry. I don't know how come this is disconnecting automatically. It is not because of automating. The limit is more, and this is only my laptop. Tomorrow I'll do one thing. I may give you Zoom meeting link tomorrow. Okay, we'll try with Zoom. Okay, and we'll see. And I'll change my laptop today possibly. And what I'm going to tell you is, with these points, we'll wind up. I am going to draft the points, whatever I have given diagram here. The same points I am going to draft here. Just only drafting, nothing to explain further. We'll close for today, and we'll continue tomorrow. Let me save this document. Inheritance 2. Inheritance 2. This diagram also I will share you. So what are the points I am going to write? These points, like two applications, two classes must be in the same application, or two classes in different application. One should be framework and another one should be implementation. Implementation class can be inherited from framework app class. Implementation app class can be inherited from framework app class. Now, third point. Third point is that we can define inheritance relation between two classes, right? We cannot define inheritance relation between the classes of two applications when there is no FW and IMPL relation. There is no FW and IMPL relation. And also between two implementation apps also we cannot define inheritance relation. We cannot define. Third one is, we cannot define inheritance relation between FW class, FW app class cannot be inherited from IMPL app class. It is not possible. So implementation application class can have inheritance with the framework application class, but framework classes cannot be inherited from implementation. Reverse is not possible. Parent to child is possible. Child to parent is never possible in the concept of inheritance. These points, if you are clear, then these are the points we are going to apply in our day-to-day development. So is this clear, everyone? First two points, if you are clear, that is pretty much fair enough. If only these two possible, remaining everything is not possible. I'm sorry. Remaining everything is not possible. Just give me 1 minute. Parent class will always, you can assume that parent class will always be in the same application or in the framework application. Parent class will always be in either in the same application or in the framework application. Parent class will be always in the same or framework application. That's it. I will give the audio to this. Maybe probably that will solve my issue or something. Okay, is it clear, everyone? Okay, I'll write down that point as you told. Parent class must always be within same application, within same app or FW app. That is one that is one clear cut point. Okay, any doubts in the inheritance relation? Anyone has any doubts? So the same thing I am going to apply in practically, but I have to tell you, how can you define inheritance relation between two classes in PEGA? How you define? What are the different types of inheritance available in PEGA? That is a continuation of today's class that we will be taking tomorrow. Tomorrow, what are we going to look at? Jan 30, 2025. Two types of inheritance. Two types of inheritance in PEGA. In PEGA, we have two different types of inheritance. Okay. After I explain this, I also have to explain you the concept of two types of classes. What is that? Two types of classes. One is concrete class. Second one is what?
Abstract.
Abstract class. These points you need to learn actually. See, you will be using concrete plus abstract classes. This is there in the object oriented programming concept. Once these two topics are over, then we are good to start discussing about the rules. Application over, classes over, then inside classes what you have? Rules. We'll start discussing about rules. First we will discuss about rules related to rules. About rules. Rules relate. I did not tell you so far what is a rule. You will be learning soon. Rules related to user interface. User interface rules. User interface related, comma, transaction related. Transaction related rules you will be learning. So once the discussion is over about the rules related to UI and transaction, we are good to create